Hello and welcome. In this video tutorial, I want to help you how to solve a quadratic equation by completing the square. If you need to review how to complete the square, I encourage you to check out my other video on completing the square. If not, let's begin with example number 1. Example 1, solve the equation by completing the square. In order to identify the value that's needed to create a perfect square trinomial, I will use this recipe, getting the b term, dividing it by 2, and then squaring it. Keep in mind that the b term is the coefficient of x. In this example, that's going to be the negative 14. So I'm going to get negative 14 divided by 2, and then I'm going to square that. If I simplify what's inside of the parentheses, negative 14 divided by 2, that's going to be negative 7. And negative 7 raised to the second power, that's negative 7 times negative 7, which gives me a positive 49. So in order to complete the square using these two terms, I need to add a 49. So here, I'm going to add 49 to both sides of the equation. So I get plus 49 and plus 49. On the left-hand side, I have the trinomial x squared minus 14x plus 49. And on the right-hand side, 0 plus 49 gives me 49. I can exchange the perfect square trinomial for a binomial squared, and to do that, I'm going to grab x and add half of the coefficient of x. So half of negative 14 is negative 7, and adding by a negative is the same thing as subtracting. So here, I'm going to get minus 7 and raise this to the second power. I have my binomial squared. This equals 49. I'm trying to solve for x, so I need to isolate x. But before I can do that, I need to get rid of the square. I can do this if I take the square root. So I'll have to take the square root of both sides of the equation. And on the left-hand side, the square and the square root are going to cancel out, leaving me with x minus 7. And the square root of 49, I'm going to get two solutions. I'm going to get plus or minus 7. Now I can isolate x by adding 7 to both sides of the equation, leaving me with x equal to 7 plus or minus 7. I have two problems here, so I'm going to break this down. I'm going to break them down individually. So I have x equals 7 plus 7, and I have x equal to 7 minus 7. Here's 7 plus 7, that's going to be 14. So I get that x is equal to 14 as my first solution. And then 7 minus 7 here on the right, that's going to be 0. So my second solution is x equal to 0. Let's look at the next example. Example 2, solve the equation by completing the square. Like in the previous example, in order to identify the value that's needed to create a perfect square trinomial, I will use this recipe, getting the b term, dividing it by 2, and then squaring it. In this example, the b term is the positive 12, since that's the coefficient of x. So let's go ahead and grab 12, divide it by 2, and then we're going to square that. We begin by first simplifying what's inside of the parentheses. 12 divided by 2 is 6, and 6 to the second power is going to give me a 36. So we're going to add 36 to both sides of the equation, plus 36 and plus 36. On the left hand side, I'll have the trinomial x squared plus 12x plus 36, and then on the right hand side, the 13 plus the 36 is going to give me a 49. On the left, I can factor the perfect square trinomial into its binomial squared by grabbing x and adding half of the coefficient of x. So half of 12, that's going to be 6. I square this, and now I have the binomial squared. I need to isolate x, but before I can do that, I need to get rid of the square. So I'll square root both sides. On the left, the square and the square root cancel out, leaving me with an x plus 6. And on the right hand side, the square root of 49 is going to be 7. But again, since we're taking the square root, we got to take into consideration the negative 7 as well. So I'll write that as plus or minus 7. To isolate x, now I can subtract 6 from both sides, and I'm left with x equal to negative 6 plus or minus 7. Keep in mind that this is two problems in one, so I'll break this down into x equal to negative 6 plus 7 and x equal to negative 6 minus 7. Let's simplify the left equation first. So negative 6 plus 7, that's going to give me a positive 1. So the first solution is x equal to 1. On the right, the negative 6 and the negative 7, that's going to simplify to a negative 13. And that is the second solution. Let's look at one last example. Example 3, solve the equation by completing the square. In this example, we already have a trinomial on one side of the equation. And to complete the square, we use the x squared term and the x term. So I'll move the negative 14 to the other side of the equation. And I can do that by adding 14 on both sides. So on the left-hand side, now I'm going to have the x squared minus the 4x, which is the binomial that I need in order to begin to create a perfect square trinomial. On the right-hand side, the 0 and the 14 is going to give me a 14. Now that I have a binomial, I can begin to identify the value that's needed to create a perfect square trinomial. And to do that, I need to use this recipe, getting the b term, dividing it by 2, and then squaring it. Remember that the b term is the coefficient of x. Here, that's going to be the negative 4. So let's grab negative 4, divide it by 2, and we'll square that. Let's simplify what's inside of the parentheses first. So negative 4 divided by 2 gives us a negative 2. And when we square that, negative 2 being raised to the second power is going to give me a positive 4. So in order to complete the square using these two terms, I'm going to need to add 4. But because we have an equation, I need to add 4 to both sides. So here we get plus 4 and plus 4. On the left, I'll have the perfect square trinomial x squared minus 4x plus 4. And on the right hand side, the 14 plus the 4 is going to give me a positive 18. Now I can exchange the perfect square trinomial into its binomial squared. And I can do that by grabbing x and adding half of the coefficient of x. Half of negative 4 is going to be negative 2. And again, adding by a negative is the same thing as subtracting. So here, x minus 2, we're going to square that, and now I have the binomial squared. That's going to equal 18. To isolate x, we first have to get rid of the square, and I can do that by square rooting both sides of the equation. On the left-hand side, the square and the square root cancel out, and we get x minus 2. And on the right-hand side, 18 is not a perfect square. You're not going to find an integer such that when you multiply it by itself, you're going to get the 18. So here we are going to write this as plus or minus radical 18. Now to isolate x, we can add 2 on both sides. And we're going to be left with x equal to positive 2 plus or minus the square root of 18. Now we can actually still simplify this a bit further. While 18 may not be a perfect square, we can still simplify the radical. And to do that, we will begin by exchanging the 18 for its product of primes. So I'm going to do the prime factorization. So 18 is the same thing as 9 times 2, and the 2 is prime. The 9, I can exchange that for a 3 times 3, and here the 3's are prime. Remember that a prime number is only divisible by 1 in itself. That's how I know that 3 and 2 are prime, because the only divisors are itself and 1. So now what I have here is x equal to 2 plus or minus the square root of, and I'm going to order these from least to greatest, so I'm going to put 2 and then 3 times 3. Because I'm taking the square root, I'm going to be looking for pairs. And here I have a pair of 3. I have two numbers of the same value. And for each pair that I find, I can exchange that for one of that quantity. So one of them is going to come out of the radical. The 2, I cannot pair it with anything, so that one's going to stay inside. So our simplified solution is going to look like x equal to 2 plus or minus 3 radical 2. And that would be the final solution. Something to clarify is that whenever you get a radical in your solution, if they ask for the exact solution or the closed solution, you will leave it like that. You wouldn't combine them. So here it's understood that the two solutions are 2 plus 3 radical 2, and the other solution is 2 minus 3 radical 2. If you were taking a look at an application problem where you're trying to estimate something on the x-axis, then you would get the decimal approximation here and add it by 2. Other than that, you would just either express your solution like this or individually like these ones.